All right, so we're going to do trigonometric ratios. This is the fifth section of this unit, 8.5. And we're going to be talking about a triangle here. We've got triangle ABC with the angles, but I want you to also notice that I have the sides marked, side A, side C, and side B. I want you to notice, I'll point this out to you again later, that angle A is opposite side A, angle B is opposite side B, and angle B, C is opposite side C, and notice that all the angles are uppercase, but the sides are lowercase, and that's on purpose. That's on purpose. All right? We're going to talk about some ratios. There are 3 ratios. One called sine, one is called cosine, and one is called tangent. If I drew a smaller triangle, and I called this one A with a little dot called prime, and B prime, and it's pretending it's right, and C prime. If angle A was congruent to angle A prime, and since they're both 90, these would be similar triangles. And if I took their sides, little b prime over b prime, I would get the same fraction if I did c prime over little c. This would reduce to the same number. So I wouldn't have to worry about the lengths of the sides. I could find their ratios. And that is exactly what sine, cosine, and tangent is going to do. You in your formula madness have written down that sine A is opposite over hypotenuse. So I'm going to explain what that means now. We have sine and we have angle A here. And so we look at A, which is right there. And I am going to find the opposite of A, which is side A. That's why there's an A right there. And the hypotenuse is the one always that's opposite the 90 degrees, and it's C. So for sine A right here, we have the ratio of the length of side A over the length of the hypotenuse. For cosine, you have written for your formula madness that it's the adjacent over hypotenuse. For the angle A, the adjacent one is the one right next door, and the hypotenuse is always the one opposite the 90 degrees, so we have B over C. The last one of our trigonometric ratios for today is tangent. We're going to do tangent of A. So we're going to do still A here. Tangent is opposite over adjacent. The opposite one is over here, and the adjacent one is right here. So it's no longer have a hypotenuse. We've been writing these down for a while for our formula madness. You just blindly memorized these things, and now I'm giving you some reference for a triangle for them. As I was looking this up, I thought to myself, where did they get the word sine and cosine and tangent? And and I was really interested to find out that back in the times of the Greeks, and even into Latin, they were using these words to refer to things like bows and arrows. And I thought that was so cool, because at our family, we're really into that. And so the whole word hypotenuse means to stretch under, like from a bow. And so I got a picture of a bow, and I just pulled one up. And I want you to notice that here we have a triangle. And if this would have been a right angle right here, this would be the hypotenuse, and it was stretched by the bow. Okay? This was part of the bow that was stretched. And so I thought that was kind of cool, if this was the right angle, which mine does not look like a right angle, but this would have been the hypotenuse, and that would have been the bow that was stretched by the arrow. I thought that was kind of cool. Something else to maybe help you remember, the word sine was the Greek word for sinus, and we're kind of ironic that we're sick right now, but it means to bend And when we were doing sine a minute ago, if you remember, sine was the opposite over the hypotenuse. And so if this is the angle that we're using, this is the bow part that is bent in that triangle, and that is the opposite for the opposite, okay? So sine had to do with being bent. I thought that was kind of cool. Cosine was actually the word co and sine put together, like complement. This is actually a Latin word, complement of sine. The complement means like adds up to 90 degrees. And if this angle right here added, if this one was what we were using with sine, this one would have been its complement, which would have been over here for its opposite. So that would have been its adjacent one here. And last one, tangent. Tangent just means to touch. And when we were doing our angle there was tangent, if we had our triangle, the tangent were the two that were touching each other. These were the only two that touched each other with no hypotenuse at all. So those are just some background on sine, cosine, and tangent. Here's something that's used to help people memorize sine, cosine, and tangent. It's a pretend word. It is not a real word. And it geometry teachers like to make up stories about some great geometry Indian chief named Soh CAH. And the SOA stands for the sine, and the O and the H. Here are the first letters of the S for sine, O for opposite, and H for hypotenuse. And the COA, or CA, Soh CAH, which would be the C, the A, and the H. And the last one, the TOA, being the T, the O, and the A. If this is something you want to use to help you memorize, I would suggest at the top of your assignment sheet, you just always write the SOH, CAH, and TOA, at the top of your page, and you'll know which one's sine, cosine, and tangent all the time. And after you write this enough times, you'll have that figured out. You'll just know that sine is opposite and hypotenuse. You'll know that cosine is adjacent and hypotenuse. And you'll know that tangent is opposite and adjacent. Another one that I found that many of my students throughout the years have used is a phrase that says, Oscar had a hold on Arthur. Oh, back up. This one does not have the sine or cosine or tangent in it at all. The first two are the sine. That's the O and the H. The next two are the cosine. That's the A and the H. And the last two are the tangent, which are the O and the A over here. The last one I found just recently, and I found it because we have people who love horses in our group, and it has to do with horses. And it's some old horse caught another horse taking oats away. And this has the sine in it, the S and the O and the H together. The CAH, which is the cosine in it. And the taking oats away has the tangent in it, the OA. So if you just either write these at the top of your page or keep them in your mind, little rhymes to help you memorize them. Does anybody have any ideas which one they're going to use?
Not really, but I'll probably end up using all of them at least once.
Okay.
Maybe. See which one works best.
Brett, do you have anything that you want to try to use?
I'll probably find one that I want to try to use.
Okay. And Heidi?
Yeah, I'll probably use one of them.
Okay. What I'd like you to do now is to get your calculator out. All of you should have a calculator, and the ones that I saw in class will work. I've got one that's similar to yours, Amy. It has the buttons in the same spots. Okay. All of the buttons should be very close to each other that we're going to be using. Your homework, and if you'll get your assignment sheet out, we're going to do the first three numbers on your assignment. It's 8.5. We're going to do them together with your calculator. I think these problems on your calculator are going to be the easiest because you're just going to type numbers into your calculator and write the answers down. You've been waiting for this for your whole life.
What? Just to figure out what these buttons mean?
No, just to be able to just type something in your calculator and be done.
True, but every single time I would look at my calculator, I would type all these random ones in, just trying to figure out what they were.
Mm-hmm.
But I would always get something saying like error on it.
Yeah.
And it's something wrong.
Yeah. Okay, your calculator has the sine, cosine, and tangent buttons. And there's about, Amy, yours are about in there. And they all should be right next to each other. And usually it goes sine, then cosine, and tangent. And
Yep.
yours, Brett, and Heidi should be close to each other.
It's number 1, 0.35.
Just 1 second. We got to make sure you're in the right mode also before we go. And I'll let you know if that's the right answer in just a minute.
The reason I was asking, or the reason I'm asking this now is because he said that, but mine came up with like 0.83.
Yeah, so we need to make sure in the right mode. Yours needs to be in degree mode. And so, Brett, I remember seeing on your calculator a little mode button. And I think, Amy, yours for sure is right where I've circled. And yours should be close to that, Heidi. Somewhere in there you got to get it to make sure it says DEG at the top. Or,
It does.
okay, and so, hi, Amy, if you'll make sure you click on that and make sure it's in degree mode. What about you, Brett?
Should it be in classic or half print?
One more time, classic or what?
Half print?
I don't know. I don't think that matters. It just that it should see DEG or RAD. What's
I have both options.
okay? So just make sure you have it in DEG, not RAD.
Yes.
Okay,
Wait, is RAD radian in degree?
that is correct. You want degrees, not radians.
Okay, I've got a lot of other things on here, and I don't know if it's just...
Yeah, don't worry about anything else. Everything else has been working on your calculator, so it should be fine. Just make sure you have degree mode.
Okay.
All right, so now let's go ahead and let's try some and make sure we get them correct. I want you to, your assignment, your very first one, we're going to give 4 decimal places for this, and I want you to type the sign button and then 21.
I got 0.3583 ...
That's what I got, and when I got that, you're going to round to 4 decimal places.
Yeah.
So,
You would round the 6 to make the 3 a 4.
yes. I want to make sure before we go on, Brett, did you get that also?
Yes, ma'am.
And what about you, Heidi?
Yes, ma'am.
Okay, so from here on out, it's pretty straightforward then. For tangent, that was number 1, by the way, we just did. We're doing number 2 now, and it's tangent 55, and I hope you got 1.4281.
Yes, ma'am.
I did.
Yeah.
I wanted to try out sine, cosine, and tangent before I just let you go. Oh. And so, next, number 3 is cosine 85. And I hope you got 0.0872.
Yes,
I
ma'am.
did.
Yes, ma'am.
The rest of those problems we did the first 4, and now you guys do the next 4 by yourselves later. You just type them in.
Later.
Yep. We're going to move on.
Okay.
All right? You can just watch this right now if you'd like. Or let me just see. This might be one of our problems together. Nope, we're just going to watch this one together. You just watch so you'll know how to do the rest of your problems, okay? If you remember, sine, what is sine? Is that opposite hypotenuse? Is that adjacent hypotenuse? Is that opposite adjacent? What is that?
Opposite hypotenuse.
Yes, it's opposite over hypotenuse. My pin, for some reason, is having a lot of trouble today. I think it's just the internet connection. All right, we're doing, and notice it says R. It's really important that you know which angle, because which one's opposite of R?
5.
5 is opposite. That's correct. Opposite. And so we have a 5 over the hypotenuse. How much is the hypotenuse?
X.
It is X. We have to find it. How are we going to find it?
Have Pythagorean theorem.
That is exactly right. We have to use the Pythagorean theorem, but I want you to notice this triangle, though. We have a 5 here and a 12 here. So what should be there?
13.
Yes, it's one of our Pythagorean triples. So I'm just going to write the 13 here. And so this will be 5, so sine r will be 5 over 13. Cosine of r, cosine is what over what? Is it adjacent, hypotenuse, is it opposite, is it what?
Adjacent over hypotenuse.
I heard hypotenuse. What was the top one?
Adjacent.
Yes, adjacent. Which one's the adjacent one to r?
12.
12, okay. And the hypotenuse is the 13 we had a moment ago, right? So cosine of r will be 12 over 13. Last one of this part, we have tangent of r. What is tangent? Opposite, adjacent, hypotenuse, what is that?
Adjacent over.
Opposite.
Yes.
One more time. It's what over what?
Adjacent over opposite.
No.
Wait, so
Opposite over.
it's going to be opposite over.
Yes, opposite over adjacent. Good job. Okay, so of r, which one's the opposite? 5, and the adjacent's 12. That's correct. So tangent of r is 5 over 12. You with me so far?
Yes, ma'am.
Let's move on. We're going to now do it with angle S. We're going to have everything referring to this S. Sine is sine opposite hypotenuse. What is that one?
Opposite over hypotenuse.
Opposite over hypotenuse. I agree. Which one's the opposite of S?
12.
Yes. And the hypotenuse is? 13. So it should be 12 over 13. I want you to notice that sine of S is the same as cosine of R. All right? What about cosine S? Cosine is that adjacent hypotenuse, hypotenuse adjacent, is it
Adjacent over hypotenuse.
adjacent over hypotenuse? We're looking at S, notice, so we're going to go S. Which one's the adjacent to S?
5.
5, and the hypotenuse is?
13.
13. So cosine S should be 5 over 13. Tangent of S, tangent is what over what?
Your screen just went white.
Mine did?
Yes. Wait,
Did it go that way for everybody?
it's back.
All right. Okay. Is everybody else seeing a good screen for me?
Yes, ma'am.
Okay. So tangent is hypotenuse, adjacent, opposite, what?
Opposite over adjacent.
Yes. What's the opposite of S?
12.
Good. And the adjacent?
5.
All right, so it should be 12 over 5. I want you to notice, had you noticed a moment ago about the sine of this one was the cosine of that one. But the cosine of this one is the sine of that one, so that's cool. What's the relationship between the tangents?
Well, it's like
It's the reciprocal.
Very good. It's the reciprocal. Very good. All right, now let's move on to doing examples like your homework. Because that's what you really want to know about is your homework. You want to be able to do it. I know you want to know the other stuff because you're so interested in this, but you really want to do your homework too.
Yes.
So you need to make sure you figure out what angle we're referring to. We're referring to A, okay? So whenever we're doing anything with opposite or adjacent, we're always referring to A. And sine, we have to remember, is sine is that opposite and hypotenuse, is that adjacent hypotenuse, opposite adjacent, what's that?
Opposite.
Opposite over hypotenuse.
Okay, opposite over hypotenuse. And I would suggest that at the top of your paper, if you can't remember that stuff, my students did the SOH and CAH and TOA, and it's right at the top of your paper. You only have to write it once on that page, and then you have them all the time, unless you want to just leave your little sheet next to you all the time. Not a problem. Okay, so it's hypotenuse, opposite over hypotenuse. What's the opposite of A?
40.
And the hypotenuse?
41.
Very good. That's our answer. Be careful, though. Can you reduce 40 over 41?
No.
No. But if you can, you need to. So be careful because there's some down here that we're going to have to reduce. Number 10, cosine is the CAH. That's adjacent over hypotenuse. And we're referring to x. Which one's the adjacent?
A. 8.
And the hypotenuse?
17.
Good job. Can I reduce 8 over 17?
No.
No. Okay. Tangent of A, I'm going to circle the A, and tangent over here was the TOA, that's opposite and adjacent. Oh, boy. Okay. Opposite of A is,
16.
16.
and adjacent.
30.
Can I reduce the 16 over 30?
Yes.
Okay, what can I take out of both?
2.
Yes, so I'll have 8 over
8 over 15.
15. Almost.
Oh, wait, that's a 30.
Okay, so I've done a sine, I've done a cosine, I've done a tangent. I'm going to let you do this one, and just when you're done with this one, tell me I'm done so I can check you. Okay?
I'm done. I'm just making sure I don't have to reduce it.
Okay.
I'm done.
All right. So tangent, I hope that you remember the tangent was opposite over adjacent. And the opposite is 27. The adjacent is 36. But I have to reduce. I can take, I believe, a 9 out of both of those. If I take a 9 out of that one, it'll be 3. And a 9 out of that will be 4. I got 3 over 4. Did you guys get 3 over 4?
That's what
Yes,
I
ma'am.
Okay, great. All right. That makes me feel like you guys are catching on. All right. Now, we're going to use that sine, cosine, and tangent to actually find some missing lengths. Okay? And this, I believe this is one of your homework problems. Just one second. Let me find.
17.
I say mine says 19, but I might be wrong. It is actually, I am wrong. This is 17. Heidi, you're right. It's 17.
Your screen just went white again.
Is it still white? Hi, Amy?
No. Okay, we're good.
Okay. All right. What we have to do is keep that that sine, cosine, and tangent stuff in front of us in some way so that we can have those in our minds of which one, because we're going to have to decide, this time we're going to have to decide which one we're going to use, either sine, cosine, or tangent. And so we're trying to find the hypotenuse. So if we're trying to find the hypotenuse, we only can use sine or cosine because tangent doesn't have a hypotenuse. We have an angle here, and we know the opposite. No, excuse me. That is the opposite, and we know and we're looking for the hypotenuse. So we have to do opposite and hypotenuse. Is that sine, cosine?
Cosine.
It's Is it cosine? Because we're looking at this, we got the opposite and the hypotenuse. Which one is opposite and hypotenuse? It's sine. All right? So we're going to use sine. So I'm going to write the word sine. Whenever we do a sine, right after we do sine, we always do an angle measure. And the only angle measure and the one we were using was the 71. So we're going to put sine of 71 equals. We said that sine was opposite over hypotenuse, and opposite is 18, and hypotenuse is x. Are you with me so far?
Yes, ma'am.
Yes, ma'am.
Now we have to solve this for x. Many a time ago, someone was asking me about that switching the means and extremes thing. I'm going to pretend that that's over 1 right now. X is in the denominator, and to solve this, we need it to be up. So if I switch these two, which is legal with the means and extremes, I'll have what I'm looking for. I will have x come on, equals 18 over sine 71. This is where that means and extremes switching things can really help. If you wanted to, you could have just multiplied, doing the cross multiply and multiply those two things out and multiply these out and divided, and you'd have all these extra steps. The means and extremes is going to be much better and faster. Is there any questions about that?
Do we have to keep this, the sine, cosine, and like tangent thing inside our equation?
Now you're going to put this into your calculator and get a decimal answer. If you look on number 17, it says to round to the nearest tenth, and so you're going to have one decimal place. So what you're going to do is on your calculator, you're going to type it in like this, 18,
Okay.
your divide key.
But do we have to write like just one place after the decimal point?
Yes.
Like before that you said before?
1 point after the decimal.
Okay.
So you're going to type it into your calculator. 18 divides sine 71.
I got 19.0.
19.0. Heidi, what did you get?
19.0.
Very good. 19.0. All right. Let's do another one. This is number 18. Remember, we're going to try to figure out which one we're going to use. Sine is opposite and hypotenuse. Cosine is adjacent and hypotenuse. And tangent is opposite and adjacent. I like to keep this at the top so I can figure out which one I'm going to use.
Is the 47 the hypotenuse, or is that like the... Oh, wait, never mind.
You got it?
Yeah.
It is that angle measure right there.
Yeah.
And
Just gotta...
we have an opposite and an adjacent. So are we using sine, cosine, or tangent?
Tangent.
That's correct. Whenever we write sine or cosine or tangent, afterwards we write an angle measure right there. What angle measure goes in there right now?
47.
Yes. And sine, cosine, and tangents are always fractions. It's something over something. Tangent, as we wrote up here, is opposite over adjacent. Which one's the opposite and which one's the adjacent?
12 over x.
12 over x. That is correct. All right. How are we going to solve this for x?
Do the...
There's 6 extremes.
Yes, we're going to switch the means and extremes again. We're going to flip the x and the tangent 47. Because there's an invisible 1 right there. You can see that invisible 1 now that I wrote it. All right. And then you're going to, in your calculator, type in 12, divide, tangent 47. What'd you get, Brett?
11.1.
It would be 11.2 because you rounded, right?
Okay, 11.2. Fantastic. Heidi, did you get 11.2?
Yes, ma'am.
All right, we've done a sine and a tangent. Let's do number 20. Is that 20? I'm wrong. This is number 19. We're doing the first 3. I just don't have the numbers right. All right, we're doing number 19. And we have to decide if we're using sine, cosine, or tangent.
Tangent.
Just a second, I gotta write H-T. Okay, she says it's tangent. What do you think?
It looks like...
We're doing this one, and this is this the adjacent over here, or the hypotenuse, or the opposite?
Opposite.
Opposite, and then the 20 is the
Adjacent.
adjacent. So opposite and adjacent is tangent. So we're going to do tangent. And we always write an angle measure, so 67. And what over what?
20 over X.
I'm hearing 20 over x. Is that what everybody else says?
X over 20.
So Brett, help us. Is it x over 20 or 20 over x?
1 second. It is x over 20.
It is x over 20. Opposite
Oh, yeah.
over adjacent, right? So it's x over 20. Now we have to solve for x. It's different than switching the means and extremes. How am I going to get the x is on the numerator, and we like that, but we got to get the 20 off. What are we going to do to get the 20 off?
Divide the other side by 20.
It's already being divided by 20, so we're going to multiply by 20 on this both sides, which is kind of like moving this 20 and multiplying it up there. So we'll have 20 tangent 67 equals x, and we can just type that straight into our calculator. Many of you, though, have to put a multiply in between there. Some of you, your calculator will be okay with just typing 20 tangent 67. You might try it.
47.1.
I heard,
That's what I got.
and after it's rounded, is that good? 40 what?
Yeah. 47.1.
All right, 47.1. Do you guys all understand how I got the 20 to be in front?
Yes, ma'am.
Yes, ma'am.
Okay.
Yeah.
All right, this is what we did at this lesson. You now know sine, cosine, and tangent. We set up those ratios and how to set them up. And you now know how to do the values in your calculator, and you know how to find missing pieces.